Example 2, we're given this quadratic equation. We're going to determine the reciprocal function. So we're just going to write this with 1 over our equation of x squared plus 4x minus 5. What are the x-intercepts and y-intercepts for the reciprocal function? So we're going to calculate that. For the x-intercept, you know what's going to happen, I'm sure, but we'll just show what happens again. When we plug in 0 for y and we cross multiply, we get 0 equals 1, which is not true. And so again, you're going to get none because you're going to have a horizontal asymptote here. So that's what's going to happen every time as you've seen now. The y-intercept, you're going to let y equals 1 over, and you're going to put zeros in place of the x values. And pretty quick to see that you're going to get 1 over negative 5, or y equals negative 1/5. Make sure you can see that negative sign there. So equals, and then that's my negative. C, determine the vertical asymptotes. To find the vertical asymptotes, you're going to want to find the non-permissible values. So I need to factor this. So if I'm going to factor my denominator of x squared plus 4x minus 5, so you're going to take the time to factor that. So factor it on your own, then check to make sure you've written down what I've written down here as your factors. So you get x plus 5, x minus 1. So that would mean x would equal negative 5 and x would equal 1. So those are going to be the vertical asymptotes. I now know those are going to be the x-intercepts on my y equals f of x graph, which would make sense if I was to find the x-intercepts here, we'd let y equal 0. All right, let's take a look at D. Graph the function y equals f of x and y equals 1 over f of x. So for D, I need to know the vertex. I actually know these can be my x-intercepts, so those are key points, but let's find the vertex of this graph. To do that, we'll write our equation down here again. You're going to want to complete the square. So y equals x squared plus 4x plus a blank minus 5. So remember it's b, so 4 over 2 squared. So 4 over 2 is 2, 2 squared is 4. So you're going to add 4, subtract 4. So y is equal to x plus 2 squared minus 9. So let's graph this because it asks for the original one and I would need to do that anyway. So my vertex is at negative 2 and negative 9. So I'm going to plot negative 2 and negative 9. Opens up, over 1, over 1 up 1, over 1 up 1. So that's our regular width. Over 2 up 4. 1, 2, 3, 4. Over 2 up 4. Over 3 up 9, or I can just look at my x-intercepts. I got kind of lucky on that one, that I have intercepts. I'm going to need something to work with above this x-axis because there's going to be a graph there. So I'm actually going to have to go over 4. 1, 2, 3, 4. So 4 squared means I'm going to go up 16. So 9, 10, 11, 12, 13, 14, 15, 16. So you're going to the, I think I miscounted there, sorry. Over 4, 9, 10, 11, 12, 13, 14, 15, 16. So you're going to count there. So over 1, 2, 3, 4, up 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we're going to graph our parabola. And we're going to label that y equals f of x. Okay, let's graph the reciprocal. I like to graph that right over top. So rule number 1, x-intercepts become asymptotes, the vertical asymptotes, I should say. So we're going to draw in our dashed lines with our arrowheads. X equals negative 5. We've got one at x equals 1 as well. Dashed lines, arrowheads. That supports part C when we figured those asymptotes out. We also have a y equals 0 asymptote here. So we want to make sure we've got that asymptote drawn in as a guide. Next thing we're going to do is our invariant points. So we're y equals 1. So we've got a point here. And then I should have done this one a little more carefully. It's really close to the asymptote, the way my parabola, my blue line kind of got sideways there. I'll make it a little more clear. Okay, and then where y equals negative 1, same thing. I want to make sure it's not on the asymptote, so I should have been a little more careful when I was drawing my parabola. 7 becomes 1/7. And along the asymptotes, you don't have to draw it super long because it's so close to the asymptotes. Here, 7th becomes 1/7 along the asymptotes. Key points, -9 becomes -1/9, which is just as close as you can possibly get. We've got the invariant points. You can plot the -5ths really close. I would plot this one since that's my y-intercept. But the idea is this just gets super close, kind of flattens out a little bit. Definitely the top point is the -1/9, and it goes along the asymptotes here. Sometimes the larger the grid paper, the easier it is to draw. So you can kind of consider that for yourselves too, or you can adjust your scale on there. So we're going to label that as y = 1 over f of x.